You type cat videos. Less than a second later, a video appears. That result just traveled about 10,000 miles and back in under a second. Here's how. When you press Enter, your device doesn't magically receive information, it sends something out. Your browser creates a tiny digital message called a request. Think of it like a small envelope that says, "Please send me this page." That envelope is often called an HTTP request, but what matters is the idea. Your device is asking for something. That request leaves your laptop through a cable or through Wi-Fi waves and reaches your router. The router is the door between your home and the rest of the internet. Everything going in or out passes through this box. From there, the request moves into a much larger network run by your internet service provider, and then onward into the global internet. But there's a problem. The internet doesn't understand names like Google.com. Computers don't navigate by words, they navigate by numbers. So before your request can go anywhere useful, your device has to ask a question. What number belongs to this name? That's where DNS comes in. DNS is the internet's phone book. Your device looks up the name you typed, like google.com, and DNS responds with a number called an IP address, something like 142.250.80.46. Every website has one. As soon as that number is found, it replaces the name on the envelope. Without DNS, using the internet would mean memorizing numbers forever. Now your request has a real destination, but it still doesn't travel as one solid piece. Instead, it gets broken into many tiny chunks called packets. Imagine taking a letter and cutting it into 10 pieces. Each piece gets labeled so it can be put back together later. These packets don't all take the same path. Each one can travel through a different route across the internet, depending on traffic and availability. It's like sending 10 taxis instead of one bus. Some routes might be faster, some might be slower. If one path breaks, the others keep going. This design is why the internet keeps working even when cables are cut. Eventually, all of those packets arrive at the same place, a server. A server is just a powerful computer that stays on all the time. Inside, it stores files and runs software that knows how to respond to requests. When your packets arrive, the server reassembles them, reads the request, finds the right file, like that cat video, and prepares a response. That response is also split into packets and sent back across the internet toward you. They travel through networks, routers, and cables, sometimes under entire oceans as pulses of light moving through fiber. As those packets arrive back at your device, your browser starts reassembling them immediately. That's why pages load piece by piece. Your screen fills in as the data arrives. Once enough packets are in place, the video appears and starts playing. Now, zoom out and look at the full journey. Your device sends a request to the router. The router sends it to your ISP. DNS translates the name into a number. The data crosses long-distance fiber, often under the sea, to reach a server. Then the response makes the same trip back to you. All of that usually takes under 300 milliseconds. 10,000 miles, 5 main steps, about 0.3 seconds every time you click. Now you see it. Which part surprised you the most, the DNS lookup or the packets taking different routes? Vizibyte, tech made visible. New video every week.